Hello, let's continue practice set 2.2 question 5th. In figure, point T is in the interior of rectangle PQRS. Prove that TS square plus TQ square equals TP square plus TR square. As shown in the figure, draw seg AB parallel side SR and A dash T dash B. Okay. Here you may note quadrilateral PQRS is a rectangle and T is any point in interior of rectangle PQRS. To prove TS square plus TQ square equals TP square plus TR square. Okay, and he gave a statement in a bracket that we are going to use as construction. Draw AB parallel SR such that A dash T dash B. Okay, now let's start a proof. Quadrilateral PQRS is a rectangle and therefore angle P equals angle Q equals angle R equals angle S equals 90 degree. Since angles of a rectangle. Okay, we know that every angle of rectangle is a right angle and that's why it is called as rectangle. Also we know that opposite sides of rectangle are equal, therefore PQ equals SR and PS equals QR. Since opposite sides of a rectangle. Okay, now in a quadrilateral ABRS, AB is parallel to SR, A dash T dash B, and angle S equals angle R equals 90 degree. We know that if in a quadrilateral one pair of opposite sides is parallel and at least one of the angle is right angle, then rest of the angles are also right angles and that quadrilateral is a rectangle and therefore we can say here, therefore quadrilateral ABRS is a rectangle. Okay. Similarly, we can prove that quadrilateral ABQP is a rectangle. Similarly, we can prove that quadrilateral ABQP is a rectangle. Okay, and therefore we may declare there angle A equals angle B equals angle R equals angle S equals 90 degree. It is in a case of a rectangle ABRS, and in a rectangle ABQP angle A equals 90 degree, angle A equals angle B equals angle Q equals angle P equals 90 degree, because every angle of rectangle is a right angle and opposite sides of a rectangle are equal, means we can prove AS equals BR, AB equals SR, AB equals PQ, AP equals BQ. Okay, let's mention here AS equals BR, then AP equals BQ. Let's call it as equation first. Since opposite sides of rectangles, okay, because AS and BR are the sides of rectangle ABRS, and AP and BQ are sides of rectangle ABQP. Okay, now in a triangle TAS, angle TAS equals 90 degree, and therefore TS square equals TA square plus SA square, or AT square plus AS square. We can write AT square plus AS square. Let's call it as equation second. Similarly, in a triangle TBQ, angle TBQ equals 90 degree. Okay, here we applied Pythagoras theorem. Since Pythagoras theorem, similarly we may apply Pythagoras theorem to this triangle, and that gives us TQ square equals BT square plus BQ square. TQ square equals BT square plus BQ square. Equation third, since Pythagoras theorem, in a triangle TAP, angle TAP equals 90 degree, and therefore TP will be the hypotenuse. Therefore TP square equals again AT square plus AP square, AT square plus AP square. Equation 4, since Pythagoras theorem, and now last triangle TBR. In a triangle TBR, angle TBR equals 90 degree. Angle TBR equals 90 degree. Therefore TR square equals BT square plus BR square. BT square plus BR square. Equation 5, since Pythagoras theorem. Okay, now what we have to prove? We have to prove that TS square plus TQ square equals TP square plus TR square. Means at LHS we want TS square plus TQ square, and at RHS we want TP square plus TR square. Okay, now let's add those equations we will contain at the LHS, TS square and TQ square. Equation second gives us TS square, and equation third gives us TQ square. Therefore now equation 2 plus equation 3 gives us, now equation 2 plus equation 3 gives us, what it gives us? LHS get added with LHS, TS square plus TQ square, TS square plus TQ square, that equals, right sides are AT square plus AS square plus RHS of equation third is BT square plus BQ square. Let's call it as equation 6th. Similarly, to get TP square plus TR square, we need to add equation 4 and 5. Similarly, equation 4 plus equation 5 gives us LHS will be added with LHS, RHS will be added with RHS. Okay, means at the left there will be TP square plus TR square. Okay, equals, now right sides are AT square plus AP square and BT square plus BR square. Let's write there AT square plus AP square plus RHS of equation 5 is BT square plus BR square, BT square plus BR square. Let's call it as equation 7th. Okay. Now, if you observe right sides of equation 6 and 7, you may note in equation 6 there is AT square. In equation 7 at the right side there is AT square. As well as we have BT square, BT square. But in equation 6 there is A square, but here is AP square. AS square and AP square. Here is A square, here is AP square, here is BQ square, here is BR square. Now AP equals BQ and AS equals BR. Means AS square we may replace by BR square, or BR square we may replace by AS square. Okay, and that's why this AS square and this BR square, AS square and BR square are one and the same. That's why we are going to replace this BR square as AS square. And now AP equals BQ, because already we proved that AS equals BR, AP equals BQ, since these are opposite sides of rectangles, because here are two different rectangles. Okay, let's replace that BR square as AS square, and AP square equals BQ square we may replace. AP square we may replace as BQ square. Let's write here. Okay, AT square plus AF square, AP square we are going to replace by BQ square, plus BT square as it is, plus BR square we are going to replace as AS square. Okay, AS square dash from equation 1 and 7, from 1 and 7. And now let's rearrange right side as right side of equation 6. Okay, that equals AT square plus AS square. Okay, we are going to exchange position of BQ square and AS square as what? AT square plus AS square plus BT square plus BQ square. Now let's call it as equation 8. And therefore TP square plus TR square equals. And therefore right sides of equation 6 and 8 are one and the same. AD square plus AS square plus BT square plus BQ square. AD square plus AS square plus BT square plus BQ square. And therefore from 6 and 8, as RHS are same, we may say their LHS must be equal. That is what? That is TS square plus TQ square must be equals TP square plus TR square. Okay. Now this is one method to prove TS square plus TQ square equals TP square plus TR square by drawing AB parallel to SR. Okay. There is one more method to solve this sum, which is related with Apollonius theorem. We are going to see that method also. Question 5th. Quadrilateral PQRS is a rectangle. T is any point in its interior. Prove that TS square plus TQ square equal TP square plus TR square. Another method to solve this question is construction. Draw diagonal PR and diagonal QS intersecting each other at point O. Okay, construction. Draw diagonal PR and diagonal QS intersecting each other at point O, and draw seg TO. Draw seg TO. Okay. On drawing a seg TO, let's see what happens. Seg PR and seg QS are diagonals of quadrilateral PQRS, and quadrilateral PQRS is a rectangle. We know that diagonals of rectangle are equal and they bisect each other. Means PR equals QS and O is a midpoint of PR as well as that of QS, and therefore OP equals OR equals OQ equals OS. Okay, and due to this we have triangle TPR, in which triangle TPR O is a midpoint of PR, and therefore seg TO will be the median of triangle TPR, and that's why we can apply there Apollonius theorem. Okay, according to Apollonius theorem, we can say TP square plus TR square. Okay, TP square plus TR square equals 2TO square plus 2PO square. Okay, similarly, we may consider another triangle which will contain TS and TQ as sides, TS and TQ as sides, means we can consider triangle TSQ. Okay, let's write these things one by one, then you will get a picture more clearly. Proof. Quadrilateral PQRS is a rectangle. Okay, we have diagonals of a rectangle are equal and bisect each other, and therefore we have PR equals QS. PR equals QS, and therefore half of PR equals half of QS. But what is half of PR? PO is half of PR, RO is half of PR, because O is a midpoint. Okay, and what is half of QS? SO is half of QS and QO is also half of QS. That's why let's write here half of PR. Half of PR we are going to write as what? PO equals OR, and half of QS, SO equals OQ. SO equals OQ. Let's call it as equation first. Now, at LHS we want to prove TS square plus TQ square. TS square plus TQ square, and that's why let's consider a triangle which contain TS and TQ and which must have a median TO, and that triangle is nothing but triangle TSQ. That triangle is triangle TSQ. Now in a triangle TSQ, in triangle TSQ, okay, in triangle TSQ, O is a midpoint of SQ. O is midpoint of SQ, and therefore TO is a median. TO is a median, and therefore TS square plus TQ square, TS square plus TQ square equals 2TO square, 2TO square plus 2SO square. Equation second, dash by Apollonius theorem. Similarly, let's consider a triangle which contain TP and TR as a sides and must have TO as a median. Okay, TP and TR, TP and TR are sides of triangle TPR. That's why let's talk about triangle TPR. Similarly, in a triangle TPR, say that TO is a median. TO is a median because O is a midpoint of PR also. Okay, and therefore we can write TP square plus TR square. TP square plus TR square equals 2TO square plus 2PO square. 2PO square dash dash by Apollonius theorem. Apollonius theorem. Okay. Now right sides of equation second and this new equation are partly same 2TO square, but at the place of 2SO square we have 2PO square. But SO equals PO, isn't? SO equals PO from equation 1. Let's replace that PO square as SO square. That equals 2TO square plus, instead of 2PO square we are going to write 2SO square. Let's call it as equation third from 1, and therefore TP square plus TR square equals. Now right sides of equation second and third are same, and therefore from second and third we have a result TS square plus TQ square equals TP square plus TR square. Hence the proof.